Hey everyone, my name is Travis and I'm a designer and developer. And today I want to talk to you about using Babel to statically analyze JSX. It's a bit of a mouthful, so let's get into some terminology here before we get started. First off, what is Babel? Babel is a source-to-source compiler, or also known as a transpiler, and it takes things like JSX and can output them to ES5 function calls. So if you've never heard of JSX, it's basically a sugar that we get to write for things like React, Preact, and some other libraries. And then they will output to function calls so they can be ran in a browser environment. So Babel does this by doing what's called an AST transformation. And so it first goes through a tokenization process. This is similar to how other compilers work. And it will spit out a bunch of information about our code. So AST stands for Abstract Syntax Tree. And this is a bit of a computer science-y term, but don't be too afraid. Basically, it just means, we have a ton of information about our code at hand, and now we can do things with that, with all that knowledge of our code. What you see here is called AST Explorer, and this is one of the more popular tools to work with ASTs. So it doesn't only work with Babel, it works with a lot of other compilers, which is really great. And so it's got a really nice interactive interface to work with when trying to dissect these things. The way Babel does its AST transformations is from a depth-first search. And so the way this works is, if you can imagine, if you have all of our nodes, we'll go to the very deepest part first. And so in this case, we'd start with A, go to D, F, and then up to C, back down to E, and then finally over to B. And this will come in handy a little bit later when we start to write our plugin. So this is just kind of give you a visualization of how it's working. So what is static analysis? We know what Babel is now, so how does static analysis play a role into this? Well, there's some tools on the market similar to Babel. One called ESLint is a very popular one. And so this allows us to set up rules for our code. And it's a form of static analysis. We're not running any of this code when we get these errors. So ESLint is responsible for linting our code and providing errors that we want. So in this case, we have an accessibility plugin running. That will tell us to wrap our emoji with an image, or with a span, with a rule of image, and then having a label associated with that so it's accessible. And so what's great about this is that we don't ever have to run our code. We know that there's an error before we even get to the browser, or before we even build our code, which is wonderful. So ESLint does a great job at this. They have a ton of plugins. Highly recommend it if you've never heard of it. Then moving on, there's another tool called TypeScript that's become very popular more recently in the JavaScript community. And TypeScript allows us, similar to ESLint, to set up this contract with our code. It does a lot more than ESLint, and at a basic level, we can see that setting up something like a title for a button, if we don't pass that, and we said that we want to pass it, our compiler will yell at us. And so before we even compile it, or it won't compile in this case, because we're saying that there's an error here. And then more advanced, say code editors like VS Code have tighter integrations with things like TypeScript, where you don't even have to compile your code. And if you have type information, it can give these to you for free. So this is where static analysis comes into play and can be very helpful especially for a large code base. So now we're ready to build our plugin now that we have a little bit of terminology down. And today, we're going to be building a layers panel of sorts. So you can think of this like, I originally built this for a design tool, but yeah, I don't know, you could probably use it for some other applications. And so essentially we'll be able to tell where all of the blocks of code are in our JSX file, as well as how many of them there are, and how they are nested and related to each other. So let's dive in and get started. All right, so now we're ready to start coding our plugin. I set up this file here, so it's got most of the things fleshed out, so we can just focus on our plugin. But just to kind of give you an overview, we have React Live set up. So this is an editor, a text editor, that's kind of showing, you can see the code here on the right-hand side. And just some basic things like the on mouse enter to highlight things once we get those that information from our Babel plugin. And just kind of like a basic React app setup here. So let's dive in and just start writing some code. So first things first, Babel expects a function for a plugin. And so we're going to export a default function here. then we need to return an object. There's what's called a visitor pattern. And this visitor pattern, we'll get back to in a second. But first we need to do something else so we can actually write JSX. So we're going to import a JSX plugin. And I already have that installed here. So this is a syntax plugin. And this is kind of required for Babel to understand our JSX. So we're feeding it some JSX, and this syntax plugin will enable us to actually read things off of that. And so coming back to this visitor pattern, we can actually visit every part of our program. So as we traverse down, if you remember maybe back the AST Explorer that I showed, this is where this will come in handy, because we can go to see like what can we visit different parts of our code. And so the first thing we want to visit in our case is our program. So program's kind of like the first thing that we're going to get into when we feed our string of text to it. So as we enter our program, we want to store some state in our case. And so, state. We want to call this tree. So in our case, we're going to call this tree. And tree will be responsible for storing all the elements as we go through each element in our. And next we will want to visit every JSX element. So that's kind of what we can do here. So this is going to get called for every JSX element. So we get back what's called a path in each part of the tree that we visit. And this path has all that information that we could see from AST on it. Babel has a specific thing called path. What you'll see in like AST Explorer is a node, but we can access that node within the path. So path just has like a ton of ways to talk to siblings or parents and things like that. In our case, we just want the node. So we'll console log this out. We're probably not going to be able to see anything. Let's see here. We pull up our console. We can clean this out. We actually need to get this to run. And so this isn't running yet. So we have this parse code function here. We have our plugin that's being imported. So how do we actually parse that code? Let's do that now. So we're using this Babel standalone transform, and this just allows us to run Babel in a runtime environment like we are right now. So this is how like Babel runs the demo site on there, like the try it out if you go to the Babel website. And we can take our code string here. So we get a code string back in our parse code function. And the second argument to transform is options. And we will get we want to pass our plugin here. And plugins takes in an array of plugins. And so we can pass our plugin there. And now we actually need to use our parse code function. If we come down here, we will create a use effect. And now, every time our code string changes, we want to do something with that. And so this is where we'll actually parse our code. So we'll say code string and use effect runs on the first initialization of your app. So once app mounts, use effect will run with this code string. So that should be good enough for now to at least get things running. And there we go. Now we can see everything popping down here. So we have all these nodes, we have all this information coming in. So similar to the AST Explorer we saw before, if we come back over here to our plugin, we get all these paths and path.node. So this is great. This is kind of what we're looking for. Now we want to start storing this information. So we can take our tree, start to push these elements into it. So we want to take the name. And so the way we can get the name is if we look in here and we dig down into the node. So we have a bunch of information about our JSX element, and we can get the name off of the opening element. And so we dig down in here, it's name. So then we finally get figure there that you can see. So we'll do path.node opening element name. That should give us what we need. While we're in here, we also want to get the start and end of the position of our JSX element. So if we can see that here. So there's an end, and then the start is down here below. You can get that information off of things like the opening element as well, but we want the whole block of. And so that's why we're going to get it off of top level part of. And so do that. And this should give us a pretty good idea of all the JSX elements that we have in our file. So come back over to our app, of our transform that we're parsing our string. So we're not actually doing anything with this now. So like, how do we get this information out of Babel? I think there might be a couple different ways you can do this. I personally like to do it, I think, the Babel way, and that would be passing an option. And so the way we pass an option is through a tuple, essentially, which will pass our plugin as the first argument, and then the second argument are options that we want to pass in. So in this case, we're going to call this onTreeReady, which will be a callback. I like to get a little fancy here. I know we can just do like a callback, but I love promises now that we've been using promises more in like new JavaScript. I think it makes things a little bit cleaner to work with. So in that case, I want to use a promise here. And so our promise will take a resolve property or function. And so we're going to pass that as an option into our Babel plugin. And so this is our onTreeReady that we have here. And so now our parse code will return a promise, and once that promise resolves, will resolve with this onTreeReady callback. So if we go down into our parse code function here, we take a string and we will return a promise now, and we want to get back a tree. And so since we already have tree up towards the top, we'll call this next tree. You can just console log this for now. We don't want to set it yet. Not yet. Make sure everything's working. And so this isn't working yet. So how do we hook up these options that we're passing in now? Let's go back over to our plugin. So a really cool way that Babel works is as we traverse our tree. So imagine that graph I showed a little bit earlier. So we go in and out that depth first. Babel gives us a way to essentially a callback for each of those things. So we can change some things here for our program. And so now our program can actually take an object as well. Now we can just delete this. And it takes an enter, exit function. And so this works for any node that we're entering or exiting. And so as before, we have our tree with an empty array. So that's how we initialize once we like enter our program. And then as we exit, we want to use that option and call the tree with those custom options. And so the first argument in here is a path, and so we don't want to deal with that really. And the next one is called state, and state is where options are held. There's some other information that comes in with state, but we're only really worried about options right now. It's called ops, and we can access that callback function that we declared in our plugin when we passed it in. So now we can take this onTreeReady and pass our tree. So you can imagine we enter our program, we start this initialization, we go through every JSX element, push all of these through into our tree, and then once we exit our program at the end, we want to have a callback. So we're passing an option in here, and that callback gets this tree that we've been stuffing all these JSX elements in. And so we did everything correctly. We should be able to see here. Now we can see at the bottom. There, that's perfect. That's kind of what we wanted to start to build our layers panel up. So this is some very simple information. So let's see if we can get this output to the screen now. So we should be able to set our tree. And see if that works. Great. Awesome. So now we're pretty much done. That was maybe not the hard part. We'll see what the hard part is here in a second. So this is great. We actually have all the information, most of the information at least that we need. The only problem is that this is a flat structure. So there's no information about the hierarchy of our code. So we can see that there's a figure here with an image nested in it, and then a div nested in that, or nested next to that as a sibling with block quotes and paragraphs and all this. So like, how do we know that information of how these things relate to one another? I was scratching my head on this when I first did this. There's a tool I highly recommend checking out. It's called Blocks UI. It's essentially a JSX design tool. And they do a layers panel in a sense. So I peeked over on their code just to figure out how they did this, and very clever on the way that they figured this out. So similarly to how we did the enter and exit in our program, we can do this with our JSX element. So I'm just going to do this, and we'll hold on to that. And so we're going to do enter. And so when we enter our JSX element, we want to push to this, to the tree like we were before. But now when we exit, so remember the graph that we showed, the depth first, we can pop off the last child. So we can say, we'll call this child, we'll say tree, call pop on it since we have an array. This will grab the last element in the array. So as we're exiting, we can take this child, and then we can also take the parent. So we know that the next item before that is the parent. So we say this dot tree, and then we take the tree length, and then -1. So this will get the last element. Now we have a parent. Now we can start to store this information. So we'll need to add a little bit more information here in our array. So we're going to call this children, and this will be an empty array initially. And then as we go through, now that we have this parent here, we can take the children of the parent, push the child to that. So we take that child off, and then we push it down into the parent's children. And before our program actually runs, since we won't have anything in here, we do need to check for the length of our tree just to make sure, or else it would error. And so we just need to make sure there's at least one item in here before we pop the child off and check for children. So this should give us an updated structure of our code. And so yeah, we can kind of see here how figure got collapsed down into one, so that's good. Back to our code here. We can just console log our code to see and make sure it's working right. Now we can see that we have a nested array with children, and it has all the information that we need and the relationships built in here. And so this is great. This is exactly what we need. Yeah, so we're pretty much almost done here, which is great. So now we can take this tree, and as we set that, I have a little function here that I already wrote, so we didn't have to worry about that. This will render the tree out with our new syntax, or the way we have children nested. And then I can use this here. And this should work. Oh, for each does not work. Tree child render. Okay. So the way we can fix this is we just want to take the first element here off of our tree, and that should fix things. Cool. And that's about it. So that gave us a way to statically analyze our code. And yeah, ran into a little bit of an issue. So it seems pretty easy at first when you first just do a JSX element. You're like, oh wow, I can enter or store all this information about all my JSX elements, and then and statically analyze them. But as you go along and you realize, oh, it's a flat structure, how do I get this relationship built up between having that enter and exit ability really helps there to build that information up. And so this is a very simple Babel plugin. I think it hopefully just gives you an intro into Babel plugins and how easy they can be to write. I was kind of mind blown when I first wrote my first Babel plugin. I took a course on it, and which I highly recommend. There's a front-end master's course by Kent C. Dodds that is a wonderful introduction into ASTs and ESLint and writing your own ESLint plugins and Babel plugins. But just at the end of the day, it's JavaScript. So if you know JavaScript, just kind of peeking around and learning the syntax, and the docs have gotten a lot better for Babel in the recent years. I highly suggest just going to the site and poking around and looking at the video section especially. There's a lot of wonderful talks about Babel and how you can use it to do some really awesome things. So yeah, thank you so much for coming to my talk, and please let me know if you write your own Babel plugin or if you were inspired by this. You can find me at SuperSerious on Twitter or souporSerious.com. Thank you so much. Have a good one.